All right, every single day, massive mechanical undertakings are happening right behind the scenes of our global supply chains. Today, we're breaking down the meticulous step-by-step procedures a massive freight train actually undergoes during a yard examination. If you've ever watched an endless line of freight wagons rumble by and wondered how they keep millions of tons of cargo moving safely across the country, well, you're in the right place. We're going to track the entire life cycle of a yard inspection from the very second a train rolls in to the exact moment it's cleared to depart.
So here's our roadmap for this explainer. We're looking at 5 key steps: arrival and rolling in checks, securing the freight rake, comprehensive air brake testing, replacing sick wagons, and finally, dispatch procedures. Let's jump right in.
Part 1. Arrival and roll-in checks.
Here is the overall timeline, the 3 major phases of this giant mechanical pit stop. Think of this as the anatomy of our inspection process. Phase 1 is arrival to placement, which is basically the intake. Phase 2 is placement to release, where the really heavy diagnostics and maintenance happen. And Phase 3 is release to dispatch, putting the train back together and sending it on its way. Let's look closely at that first phase.
Now, you might think the work starts when the train stops, but actually, the inspection kicks off while the wheels are still turning. Technicians position themselves trackside, relying entirely on their own highly trained senses to do visual and auditory checks in real time. They're visually scanning the undergear to catch any loose or hanging components that could, snag on the tracks. At the same time, listen to this. They're literally listening intently for a rhythmic thump-thump sound. That tells them there's a flat spot on one of the steel wheels. It's just an incredibly raw, highly skilled process of observing tons of moving steel.
Keep this critical threshold in mind: 90. That is 90 degrees Celsius, and it's a hard limit. The absolute second the train finally halts, inspectors spring into action with non-contact infrared thermometers. They walk the line, feeling the axle boxes on both sides of every single wagon. If they measure any axle box running hotter than 90 degrees, immediate red flag. That indicates a hot axle, a serious danger zone where friction is completely overcoming lubrication. The moment that 90-degree threshold is breached, that specific wagon is instantly marked as sick.
Before anyone reaches for a wrench, though, the administrative handover has to happen. The incoming BPC, or Brake Power Certificate, is collected. Think of this document as the train's passport and medical history all rolled into one, validating its braking capacity. But here's where the human element is absolutely crucial. Along with the BPC, the team grabs the local pilot's physical notes from what's called the RS5 register. If the pilot felt something dragging or braking unevenly out on the main line, those exact notes tell the mechanics exactly where to look next.
Moving on to Part 2. Securing the freight rake.
All right, so once the yardmaster officially hands over the rake to the maintenance team, usually via a digital T431 memo, the real diagnostic work begins. But it actually doesn't start with physical tools, it starts with data. The team jumps into the digital FMM portal to check for systemic alerts triggered by automated trackside sensors the train passed miles ago. You've got OMRS for acoustic defects, HABD for hot bearings, or WILD for wheel impact loads. If the portal flagged a wagon, the team already knows exactly what defect to target before their boots even hit the ballast.
Now, shifting from digital data to something very, very physical. They have to make absolutely sure this massive train does not roll away during maintenance. First, they verify the rake is correctly placed on the right line. Second, they slap heavy, physical skids and chains onto the wheels. Third, they lock those chains with actual padlocks. And finally, bright red stop boards go up at both ends of the train. It's kind of mind-blowing when you think about it. Thousands of tons of rolling steel, ultimately anchored by a heavy-duty padlock and a chain. It's a brilliantly simple, totally foolproof system designed to protect the technicians crawling underneath.
Which brings us to Part 3. Comprehensive air brake testing.
This right here is the heart of Phase 2. The team hooks up a specialized piece of equipment called a rake test rig, or RTR, directly to the train's pneumatic system. It basically simulates the locomotive's air compressors. They run intensive air brake testing based on super strict parameters. They verify that all components are working, listen for pipeline air pressure leaks, and count any wagons with an ineffective brake system, which they call an IOP. They measure the incoming brake power, and if they find a bad component, bam, they meticulously mark it by painting a big red X right on the wagon body. And there is zero room for guesswork here. The inspectors follow the RERK Part 3, Chapter 4 rulebook to the letter. If they spot a rejectable defect that is simply too complex to be patched up right there on the examination line, that wagon gets the red X and is officially declared sick. It literally cannot continue the journey. It's designated to be completely pulled from the train and sent over to a specialized repair area known as the sick line.
Okay, part 4, replacing sick wagons.
Now, a freight train is a finely tuned machine. It relies on specific weight and wagon counts to operate efficiently. We can't just yank out the sick wagons and send the train off short. This is where traffic operations steps in. Using a formal RS-16 memo, they physically detach those sick wagons. Then, perfectly healthy, fully fit wagons are seamlessly swapped in to take their place. In the industry, this vital topping-up process is called room completion. Once the new wagons are hooked up, the maintenance guys do a rapid cursory check just on those specific additions to make sure everything is completely integrated and safe.
And finally, part 5, final dispatch procedures.
Putting this behemoth back together takes absolute precision so we don't have any catastrophic mechanical failures. First up, engineers ensure the entire rake is in the released position, meaning no brakes are accidentally left engaged. Only then is the train ordered and the massive locomotive securely attached to the front. Next, they connect the absolute lifeblood of the braking system, the blue and yellow brake pipe and feed pipe pressure lines. These pipes have to flow continuously from the locomotive all the way back to the rear guard, basically bringing the train's entire nervous system back online. To be absolutely sure, a final continuity check verifies that the air pressure actually makes it all the way to the back.
Once that continuity is locked in, the train needs its brand new passport. A fresh brake power certificate is generated in the FMM system. This isn't just an administrative rubber stamp. It calculates the exact permissible brake power percentage based on the actual number of working brake cylinders in that specific rake. The examiner, the loco pilot, and the guard all digitally sign off on it. It's a shared promise that the math is dead on and the train has the exact stopping power it needs.
And just like how we started, this whole explanator comes full circle. As the locomotive revs up and the train starts pulling out of the yard, the team conducts a final visual rolling out examination. They're watching the undergear, listening to the wheels, making absolutely sure the departure is smooth as silk. All that hard work, the digital alerts, the heavy chains, the intense air pressure tests, it all pays off right here as the train safely rejoins the rail network. It is honestly pretty fascinating to think about the massive scale of these hidden logistics. We see these trains effortlessly winding through the countryside, but we rarely think about the rigorous, multi-phase mechanical pit stops they endured just to get out there. So next time you're stopped at a crossing, watching an endless line of freight roll past, ask yourself, just how many meticulous tests did that steel giant have to pass to make it out of the yard? I hope this deep dive into the explainer gave you a brand new appreciation for the absolute procedural discipline of our freight rail yards. Thanks for joining us, keep learning, stay curious, and we'll catch you next time.